Good morning. Please switch on your videos. मानसी गजब अपना वीडियो ऑन करिए बेटा. Then we will get started. Mahima, your camera is not properly placed. Mansi, your video is still not on. Mansi, your video is still not on. Yeah. Okay. So let's get started. So we were doing this question when we got cut out in the last class. Okay. So yellow light of wavelength 6,000 Armstrong, okay, which is 10 raised to power minus 10 meter, illuminates a single slit of width, okay, 10 raised to power minus 4 meter. Calculate the distance between the two dark lines on either side of the central maximum when the diffraction pattern is viewed on a screen kept 1.5 meter away. Okay, so here we will get diffraction pattern like this. Okay, this is the central maximum. So he is asking the distance between this and this, which is same as the central fringe width. So what is central fringe width equal to? It's double the size of lambda upon small d into the screen distance, right? We just have to put in the values. D is 1.5 and this is 1 into 10 raised to power minus 4. Okay, so this is 3 into 18 and 7. 18 millimeter. Okay, so this is a straightforward question. Okay, this we don't have to do. So I can skip this one. Okay, let's do this one. The intensity at the central maximum O in a Young's double slit experiment is I naught. Okay, so at the central maximum is I naught. If the distance OP equals 1/3 of fringe width, okay, this is 1/3 of fringe width of the pattern, show that the intensity at P would be I naught by 4. Okay, how would we do this? How would we do this? This distance is 1/3 of fringe width. Any ideas? बेटा वीडियो ऑफ हो गए हैं ऑलमोस्ट सभी के. प्लीज स्विच ऑन योर वीडियोस. दीपांशी, गजब, सना. दीपांशी, गजब. दीपांशी, यूट्यूब. ओके. सो देखिए, इस तरह के जब हम क्वेश्चंस करते हैं ना, एक हम हमेशा एक अजम्पशन लेके चलते हैं. वो क्या अजम्पशन होता है कि यहाँ जो ये थीटा होता है, ये डेल्टा थीटा या थीटा जो भी आप इसे बोले, राइट, ये क्या होता है? इट इज अ स्मॉल एंगल. व्हेन थीटा इज स्मॉल, हम क्या करते हैं कि अप्रोक्सीमेशन ले लेते हैं कि साइन थीटा भी इज इक्वल टू थीटा, और हम टेन थीटा को भी इक्वल टू थीटा ले लेते हैं फॉर वेरी स्मॉल एंगल्स. ओके. साइन थीटा भी थीटा होता है, टेन थीटा भी. यानी कि ये जो फ्रिंज विड्थ है, ओके, सो जो यहाँ पे आई वुडंट से फ्रिंज विड्थ, आई विल से डिस्टेंस हियर. ओके, ये जो डिस्टेंस है, लेट्स से ये y है, ये डिस्टेंस, राइट. सो y इज प्रोपोर्शनल टू थीटा, राइट, ऑल्दो इट इज प्रोपोर्शनल टू टेन थीटा, राइट, बट हम इसको कह देते हैं कि इट इज प्रोपोर्शनल टू थीटा. ये अप्रोक्सीमेशन हमेशा होता है, तो वी डोंट हैव टू वरी अबाउट दैट. अब बात ये है कि ये जो डिस्टेंस है, ये 1/3 ऑफ फ्रिंज विड्थ है. फ्रिंज विड्थ जो होती है, एक फ्रिंज विड्थ के लिए थीटा कितना होता है? थीटा फॉर वन फ्रिंज विड्थ कितना होता है? एक फ्रिंज विड्थ कब आती है? जब कितना फेज डिफरेंस होता है? 2 पाई. सो 1/3 बीटा के लिए कितना होगा एंगल? 2 पाई/3. ओके, सो ये जो एंगल है, ये है 2 पाई/3. राइट. तो यहां पे जो रिजल्टिंग वेव है, राइट, वो क्या होगी? क्या होगी रिजल्टिंग वेव? ये तो एक साइन ओमेगा टी होगी. मान लो एक को एक साइन ओमेगा टी मानते हैं, तो पार्ट डिफरेंस कितना होगा? दूसरी होगी ए साइन ओमेगा टी, ओमेगा टी प्लस 2 पाई/3. ये हुआ फेज डिफरेंस, राइट. तो इसको क्या लिख सकते हैं हम? ए को तो बाहर ले लो. वी विल यूज द एंगल सम फॉर्मूला. तो क्या बनेगा? ये साइन बताइए क्या बन जाएगा ये? somebody can tell me क्या बनेगा ये using the identity? साइन में क्या आएगा? इन दोनों का सम आएगा 2 ओमेगा टी प्लस 2 पाई/3/2 कॉस डिफरेंस आएगा राइट, 2π/3/2। तो क्या आ गया हमारा, a sin ω t plus π/3 into cos π/3। What is cos π/3? What is cos π/3? Cos π/3 क्या होता है, हाफ। So a/2 sin ω t plus π। तो एम्पलीट्यूड कितना हो गया यहाँ पे, एम्पलीट्यूड is a/2 and intensity will be a/2 whole square, okay, which is 1/4 a square, which is 1/4 I naught. Understood? Right, so usually the questions are not related to intensity in these questions, okay। ज्यादातर जो questions आते हैं वो fringe width related होते हैं, लेकिन ये क्वेश्चन में इंटेंसिटी पूछी गई तो हमें सिंपल एडिशन करना है विद द फेज डिफरेंस, ओके। दिस इज द सुपरपोजिशन प्रिंसिपल, okay, principle, okay, PLE, sorry, okay, so we should use the superposition principle, okay, let's do the next question. Again, this is not needed for us this time. Now this is the बेटा वीडियो ऑन करिए। there was some technical problem, I was disconnected and reconnected, but you keep your videos on. महावीश, दीपांशी, गजब, बेटा सब वीडियो ऑन करिए, वीडियो ऑफ नहीं रखना है हमें, आपको ये बात पता है। प्लीज कीप द वीडियोज ऑन। केवल निखिल का ऑन है वीडियो एंड आई कांट सी निखिल ऑल्सो, उसका कैमरा कवर्ड है। निखिल, others please switch on your cameras. But we cannot proceed without you people present. Mahavish, Dipanshi, Mansi, Mansi का on हुआ है। Now I can see Mansi. Nikhil is fine. Sandeep, Sandeep, Dipanshi, Mahavish. Sandeep, Dipanshi
सर
and
मेरे वीडियो में कुछ प्रॉब्लम हो गई है बार-बार ऑन करने से।
And Dipanshi, what about you? Dipanshi, Nikhil, your video is off again. बेटा हमारा आधा टाइम इसमें चला जाता है, देखिए आप ही का टाइम वेस्ट हो रहा है, हमारा तो हो ही रहा है लेकिन आप ही का हो रहा है ना। फाइनली तो एग्जाम आपको लिखना है, हमें नहीं लिखना है। Dipanshi and Nikhil. Please switch on your videos within 2 minutes. I will continue with this question. It is a very easy question. How will we do this? Calculate the wavelength of light in glass if the frequency of light is 6 into 10 raised to power 14 hertz and the refractive index of glass is 1.5. ठीक है ना, तो हम स्पीड ऑफ लाइट इन ग्लास निकाल सकते हैं is equal to 3 into 10 raised to the power 8 by 1.5, which is 2 into 10 raised to the power 8 meter per second. And lambda will be speed of light by frequency. So into 8 by 6 into power 14. 3.332 the 10 raised to the power. Okay. And if we want, we can write it as 333.3 nanometer. Okay, this was a simple question. Nikhil and Mansi, your videos are off. A parallel beam of light 450 nanometer falls on a narrow slit and the resulting diffraction pattern is observed on a screen 1.5 meter away. It is observed that the first minimum is at a distance of 3 mm from the center of the screen. Calculate the width of the slit. Okay, again a direct application of the formula. Okay, the first minimum comes at lambda d upon small d. And this is given to be 3 into 10 raised to the power minus 3. So we will find d is equal to lambda d upon 3 into 10 raised to the power minus 3. And what is lambda? 450 into 10 raised to the power minus 9 into 1.5 by 3 into 10 raised to the power minus 3. So 225 into 10 raised to power minus 6. So 225. Okay, so that is the width of the slit. Direct application of the formula. Two wavelengths of sodium 960 and 590 and 596 are used in turn to study the diffraction taking place due to a single slit of aperture 1 into 10 raised to power minus 4 meter. The distance between the slit and the screen is 1.8 meter. Calculate the separation between the position of the first maxima of the diffraction pattern obtained in two cases. ओके सो हम क्या कर रहे हैं, एक स्लिट है यहाँ पे, एक स्क्रीन है 1.8 मीटर दूर है, ठीक है, ये 0.1 मिलीमीटर अपर्चर है और यहाँ पे हमें एक डिफ्रैक्शन पैटर्न तो ऐसे मिला, ठीक है, और दूसरा डिफ्रैक्शन पैटर्न जो है वो हमें मान लीजिए ऐसे मिल गया. ठीक है, तो हमें जो है ये डिस्टेंस निकालना है. द डिस्टेंस, calculate the separation between the position of first maxima. ओके, फर्स्ट मैक्सिमा में डिफरेंस निकालना है. ये एक का फर्स्ट मैक्सिमा है, ये दूसरे का, तो ये डिस्टेंस निकालना है. Okay, so how will we do that? First maxima of 590 nanometer light. क्या होगा? फर्स्ट मैक्सिमा कब आता है? 3/2 lambda d upon small d. ओके, सो इसको मैं lambda 1 लिख देते हैं. और फर्स्ट मैक्सिमा of 596 light is 3/2 lambda 2 d by d. डिफरेंस क्या आएगा? Difference, I can take 3/2 d upon d as common, lambda 2 minus lambda 1 inside. The difference is 6 here, and this is 3/2 into d, which is 1.8. Small d is 10 raised to the power minus 4 into, the difference is 6. 6 into 10 raised to the power minus 9. 9 into 18 is 1.16.2, right? 16.2 into 10 raised to the power minus 5, or 1.62 into 10 raised to the power minus 4. Okay, so this is the distance between the two maxima. Again, a direct use of formula almost, right? So easy questions aate hain, but sometimes you just can't use the formula. The human eye has an approximate angular resolution of 5.8 into 10 raised to the power minus 4 radian, and a typical photo printer prints a minimum of 300 dpi, dots per inch. Okay, at what distance Z should the printed page be held so that one does not see the individual dots? Okay, so we are talking of what? The distance is how much? 1 inch, which is 2.54 centimeter by 300. This is the distance between the two dots. At certain distance x, right, we cannot differentiate between the two. Okay, and this is 5.8 into 10 raised to power minus 4 radians. Right? So this is a simple question. So tan theta for such a small angle is equal to theta is equal to 2.54 into 10 raised to the power minus 2 by 300 upon x. Okay, so x is equal to 2.54 into 10 raised to the power minus 2 by 300 into 5.8 into 10 raised to the power minus 4. Right? So let's do that. Please switch on your cameras. Again, all the cameras are off. Saurav, Mahavish. Okay, so let's do that. 10 raised to the power 2 रह गया यहाँ पे और this is 5. This will go by roughly 2. Right. And roughly 2. So this will become 1 by 600 into 10 raised to the power 2, which is 10 to. So 1 by 6 meter. Okay, meter. 1 by 6 meter or 100 upon 6 centimeter, which is 1 and 40 is 16.2. Okay. Okay, this is approximately, because I have made this approximation here. Answer the following questions. In a Mahavish and Saurav. Mahavish said her camera is not working. Saurav, what about you? Saurav, switch on your camera. Okay. In a double slit experiment using light of wavelength 600 nanometer, the angular width of the fringe formed on a distant screen is 0.1 degree. Find the spacing between the slit. Okay, so see this, note this question. This is a very, very simple question, but a lot of students make a mistake in this, right? This is known. So we have to find D. D is equal to lambda upon theta. Okay, and lambda is 600 into 10 raised to the power minus 9. Right? Now, what is theta? Can somebody tell me, can I take theta as 0.1? Mahavish, Saurav, can we take theta as 0.1 degree here? Can I take this? Mahavish, Saurav, we cannot.
Yes, sir.
We cannot take this. Why we can't take this? Because this is in degrees. remember the angle that we used when we say theta is equal to is equal to sine theta is equal to tan theta, वो जब हम approximation बोलते हैं तो theta has to be in radians, only then that approximation is true. So we are solving it in SI units, and the approximation also only works when the theta is in radians. तो ये रेडियन में लेना पड़ेगा, तो we have to convert this into radian. Okay, and the way to convert it in radian is pi upon 180. Okay, so this will become 600 into 180.314 into 10 raised to the power minus 9. Okay, so what we are going to do is make it 3 raised to the power minus 3. We'll remove this, so it is 100. 52 point. So we will just take it as 52 for the time being, just for approximation. And this is roughly is 9. Right, and so this is minus 3. This will make it 5. So 10 by 3 into 10 raised to the power minus 5, which is 3.3 into 10 raised to the power minus 5. Okay, meter. Okay, light of wavelength 5000 Armstrong propagating in air gets partly reflected from the surface of water. What will be the wavelengths and frequencies of the reflected and refracted light be affected? How, this is an easy question. How would we do this? देखिए, reflected, same wavelength and same frequency. Okay, same wavelength and same frequency. Understood? सेम वेवलेंथ एंड सेम फ्रीक्वेंसी रहेगा, रिफ्लेक्टेड में कोई चेंज नहीं आएगा, मीडियम भी सेम, सब कुछ सेम. लेकिन रिफ्रैक्टेड में क्या होगा? What will happen in refracted? Same frequency. Okay, frequency does not change. What will be the lambda? Lambda क्या होगा? Lambda will become whatever was the lambda, and lambda will reduce by mu. Okay, the mu of water is not given, but let's take it as 1.33. Okay, so 5000 by 1.33 is equal to 5000 4 into 3 कर दिया इसको for simplicity, and 3750. Okay, so that will be the wavelength in the refracted light. Okay, only one thing we have to calculate, all others will remain same. Okay, so that is all that we had in this from the board questions. Okay, so now this chapter is over. Okay, there were more, but they were polarization questions, so we will leave those. Okay, so tomorrow, not tomorrow, the next class, right, day after, what we will be doing is AC. We will revise the AC chapter, the concepts through questions, and then we will do some board questions and board like questions. So ensure you join for the AC discussion also. Any questions in the chapter so far? Mahavish, Saurav?
No, sir.
Okay, so this chapter is clear now, right? There are only 2, 3 concepts in this. Essentially, just to revise, the first is the Huygens principle. Understand the Huygens principle, its definition, okay? And try to read and do with your hand the explanation of the reflection and refraction using Huygens principle. With that, your Huygens principle will be done. Then you have to, the next topic you have to do is to do your what? Interference. Okay, interference, the Young's double slit experiment, and the formulas that we have just used, right? The fringe width formula. Okay, also understand the concept of the path difference and the phase difference that causes the different intensities. Okay, so we saw that once in a while a question comes in which we have to calculate the intensity. So wo aana chahiye. We have done it in the last class. Okay, so that we should be able to do. Okay, and finally comes the diffraction pattern. ओके, डिफ्रैक्शन पैटर्न और इंटरफेरेंस पैटर्न्स में डिफरेंसेस हमने किए थे, वो आपको याद होने चाहिए. डिफरेंट विड्थ्स होती हैं डिफ्रैक्शन में, इंटरफेरेंस में, बट दे आर स्टिल सिमिलर फिनोमिना. ओके, तो कंफ्यूज हो जाते हैं स्टूडेंट्स, उनके हमने डिफरेंसेस किए हैं अच्छी तरीके से, तो वो आपको आने चाहिए. न्यूमेरिकल्स में फॉर्मूले लगभग एक जैसे हैं दोनों में, ठीक है, लेकिन कहाँ पे ब्राइट लाइट फ्रिंज बनती है, कहाँ पे डार्क फ्रिंज बनती है, वो दोनों में ऑपोजिट है एक दूसरे का. ठीक है, इसीलिए मिडिल फ्रिंज डबल हो जाती है इन केस ऑफ डिफ्रैक्शन. बस उतना सा याद रखना है आपको. उसके बाद